Hello, hello. It is 2:14, so we're gonna get started in a second. Nice. If you cannot see the branches in Git Kraken, please tell Git Kraken that 130% zoom is not enough. This is the largest GUI branching I could find. Apologies if it's not big enough. All right. So my name is Abby, and I'm here today to talk to you about merging and rebasing. The title of the talk, #GitPanic, came from a blog series by the same name that I started writing around the second time I cried about interactive rebasing. So to that point, please do not get panicked during this talk. This is a lot of information. It's going to touch on 5 articles out of an 11-article series. I'm going to glaze over even more information, but all of that information is in the series. The repositories are linked here. The series is linked here. These slides and those links are in the Star Trek GitHub repo, and that repo is linked in the Discord in the channel for this talk. So please do not try to memorize commands. Do not feel like you have to walk out of here knowing everything that I've talked about. All of this information will be available to you after we're done. Really, what we're trying to do today is build mental models so you know what buttons to reach for. I'll be doing stuff in command line. I'm not saying that you have to do stuff in command line. Obviously, I'll be using Git Kraken, which is a GUI for Git. I can't say GUI without giggling, so we're going with GUI. And I will be working in VS Code for terminal and the VS Code source control panel. And I use GitHub all the time. So use a UI, use a GUI, just understand what we're doing. So let's start by getting on the same page. I don't promise that's the last pun. Git is version control, distributed version control. You know what version control is if you know that 2.0 is better/newer than 1.0. Distributed means that Git, like a database, is really concerned with anyone, everyone, being able to make changes at the same time and being able to reconcile those changes without overwriting any work. If you're storing something in Git, it's in a repository. The local, sometimes referred to as downstream, is the one that's on your computer. It's the one that you can see unless someone walks over and looks at your computer, then they can see it too. The remote, sometimes called the upstream, often referred to as origin, is the one that's in the GitHub UI, the cloud, someone else's servers. Everybody can see it without physically walking over to your computer. If you note, in Git Kraken, all of the branches have a computer next to them as well as a GitHub icon. The computer means it's local, it's on my machine. The GitHub icon means it's also in the remote. Because we don't have internet today, all of the changes from here on out will just have a computer next to them. Git is mainly concerned with changes. Most of the information that it stores is snapshots of diffs or differences. And here is a split diff view. You can see that the deleted code is in red on the left in its own file. The added code is in green in a separate file next to it. I find this incredibly difficult to read, especially when you start moving big chunks of code around. So I prefer a unified diff. This has deleted code in red directly above the added code in green, all in the same file. Whatever UI I pull this from in GitHub has a split button and a unified button. But if you don't see those buttons and you're looking at a diff view that you find hard to read, definitely go check out the settings. There's usually a way to change between these two. So one of the ways that we make Git's life easier when we are making changes is by using branches. We're not all hanging out in the main branch, which is the one that's created when you create the repository, tippy-typing away, hoping our changes are the ones that are chosen. Instead, we go ahead and branch out, store our changes in our own branch, and then come back to compare changes when we're ready. Comparing changes, reconciling changes, all of this is a large part of why we merge and rebase. We're helping Git reconcile the changes and choosing the work that we want. So if I want to see all my branches, I run the command git branch. I have some styling in my terminal, so you can see that main is a different color, but it also has an asterisk next to it. I also have a terminal script that runs and tells me what branch I'm in because I constantly forget what branch I'm in. So you can see we're in main. If I create a branch, let's go ahead and call it new branch. The branch naming does not get any more clever throughout this talk. Do not write the commit messages I'm writing. Do not write the branch names I'm writing. That is a different talk. So I've created a new branch, but you can see my terminal script still says main. And if I run git branch again, it still says I'm in main. New branch is there, but we're not in the context of it. So if you want to get into the context of it, you're going to have to run git checkout new branch. Because Git is like, hey, maybe they don't want to run 2 commands every time, we can also do git checkout with the B flag for branch, and then pass a branch name. And now you'll see that we're in newer branch, and we have created newer branch. So now that I have a branch, I probably want to start making changes and storing them in it. When I start typing, those changes are going to be stored in the working directory. This is the track changes that Git pays attention to. It's the ones that are not in your .gitignore file. Those would be untracked. Git is not going to pay attention to them at all. So if I start making changes, say, I think it's a really great idea to make the title of this page the Pokemon page. I think that's a great idea for SEO. I'm going to save. I'm going to check out Git Kraken, and it's going to show that I have changes in my working directory with a dashed line. These are work in progress. One feature of Git that I really love, mainly because I always forget what branch I'm in, is stash. I can go ahead and run git stash, and now Git Kraken will show me that it's actually in a dashed square now with a little inbox icon. And this is essentially putting your changes in a bucket that are next to your Git tree. You can access these changes from any branch, anywhere in Git. And this is really useful if, say you're in the middle of something, you're not ready to commit. I need to go ask someone if the Pokemon page will actually increase the SEO for my page. But now my coworker needs me to review their PR. I have to go check out their branch. I can just drop it in stash. I can use apply stash with right-click in Git Kraken. And then I'm just going to delete this because I don't need it, and we don't need it cluttering up Git Kraken right now. And for git add, I'm going to use VS Code source control panel to show you that when you run git add dot, you're adding all of the changes to the staging area. They are staged. And this is basically saying, Git, when I run the commit command, these are the changes that I want you to commit. And I used period, dot, whatever you want to call it, to say all, which implies that if you know how to reference your changes, you don't have to stage all of your changes at once. This is why we have a staging area. This is why you have to run 2 commands every time, because we may only want to commit some of our changes. And we can use this to stage by file, stage by chunk. You don't have to do all of it at once. Today, we're going to go run git commit and close the source control panel and show you that I am now in an edit window. If you do nothing, Git, when it needs you to edit something, will open a VI window. This uses Vim commands. I'm sure you've seen a meme about how difficult Vim commands are to learn, how easy it is to get trapped. I'm not saying that you can't learn Vim commands. You totally can. I'm not saying that you can't learn Git stuff. You totally can. Trying to learn them both at once is a little bit of a learning curve that you don't necessarily need. I may have cried about it multiple times. So my recommendation is that you associate a text editor with Git. You'll see later when we get to merge conflicts how helpful it can be. But if you don't know Vim commands and you get kicked into a window, it's very easy to get trapped and flustered. So you don't have to use command line at all. You can also use a UI or a GUI like we talked about earlier. So I'm going to go back to my edit window. I have configured Git to give me a template. I'm going to delete most of the template right now because we're not writing good Git commit messages in this talk. I used I to enter insert mode, Anything with an octothorpe or hash sign at the beginning of the line will be ignored. And we're going to say update page title. I'm going to hit escape to exit insert mode, colon, to tell the VI window that I'm telling it something, W for write, and Q for quit. Please let me out. So now we have a commit. And it has a solid line. It has my little default Galaga guy because I have not paid for GitKraken. And it's solid. We got a lot of information here. What kind of information, you ask? Well, a lot. There's a snapshot of changes because we know Git is obsessed with changes. You can make the code bigger than 130%, I would like to point out. And we have references, we have our commit message, we have my information, and we have a relationship to previous commits. We have information about the file or files, and we have those refs. You can also use the command git log to view all of the information about the commits that you could possibly need. Use Q to quit this view. It'll tell you what branches it's in. It'll tell you the refs. It'll tell you the information. It'll give you the commit message. And this is before I've configured anything. If you look at our seagull friend here, you can go wild with this command. I'm pretty sure you could make it make a tree like we're seeing in GitKraken. It will print out latest commits at the top. You can see a lot of information with this. I'm talking about refs a lot. A ref is a reference. It's a human-readable reference to a thing. Everything stored in Git has a ref. A branch name is a ref. Origin is a ref to the remote repository. You can create tag refs for more refs and more version control. All of them are stored in .git/refs, and git reflog will show you all of your refs. I'm not going to run it today, but you can configure it just like git log. It'll show you everything you need to know. At this point, you may be like, why are we talking so much about refs? And it's because refs are your best friend in Git. Recovering lost work is almost always possible for months. Git does not clean out the ref log for a very long time. I have a whole blog on removing and restoring work if you want to learn more about that. Just keep in mind, when we get to the scary stuff, you can probably get that work back as long as you can find a reference to it, like with reflog. Commits themselves have multiple refs. I keep referencing a ref and pointing at a random string of characters and numbers. And that's what I'm going to call the SHA. You can also call it a reference ref or hash. It's a unique identifier for a commit made using the SHA-1 hash algorithm. You'll see anywhere from 5 to 12 characters used. The Git reference documentation recommends 8 to 10 characters because Git is pretty smart about matching SHAs. The Linux kernel did find that when they hit about 875,000 commits, they did need 12 characters for it to be accurate, so just keep that in mind if you get that far in a repo. Commits also have a special ref called head. All caps, if you've checked out a branch, refers to the branch and the last commit on this branch. Lowercase head just refers to the last commit. It's not used as much. Head up caret, which is the same as head up caret 1, is the parent commit of head. We can also enter a detached head state, which we'll get to in a second. For anyone who is like, hey, I was here for merging and rebasing, you're talking a lot about like the really basic stuff that I swear I already know how to do, there is a reason for that. It's because we tend to think of commits and branches as these monoliths, but they're the individual commits and all of their relationships from the commits before them, as well as references. So if I'm saying head up caret, that's the parent commit of the current commit that I have checked out. Head up caret 2, parent commit of the parent commit. Head up caret 3 is the parent commit of the parent commit of the parent commit of head, and all the way back until you get to the commit where you ran that command to create that branch. And that is the last common commit of the base branch and the new branch that you made, or the parent commit of new branch. Now we got to detach that head. So we're going to go ahead and run git checkout head up caret. And Git is going to print out a whole couple paragraphs about how it does not like this. You are in a detached head state. You are making experimental changes. What are you doing? And this is because Git cares very deeply about the relationship of commits. If I start making changes right now, those changes will have a relationship to the commits before what's currently checked out and what's currently checked out. But we have orphaned a commit out in the ether. It is alone. It is not building relationships, and Git does not like that. So since we know we just need a ref to get back, all we have to do is find that commit in Git Kraken. We are currently checked out. Git Kraken is kind of kindly shows us where our head is at the last common commit. But I have this ref, which Git Kraken allows me to copy with one click. And I can go ahead and run git checkout with that SHA. And now, no paragraphs. Git is OK with this. We are back at the tip of newer branch, but Git Kraken is still telling me where my head is. And that's because I have checked out a commit and not the branch. To get it back to not showing me where my head is, all we have to do is run git checkout newer branch. Fetching. I won't be able to fetch because I don't have internet. But if I was able to fetch, all I would do would be downloading refs, downloading complete branches that I don't have to reconcile. It will not reconcile changes. It will just get you your new information from the remote that you don't have in the local. You can set it up to delete all of your branches that are not used in the remote, and there's the command to do that. So, if I could fetch, that would be great for me, because if I mess something up later, I could just delete my local branch and then fetch a new one from the remote, which means when we start doing scary stuff, the first thing we do is push up all the changes we care about, because if we mess up, we can just delete the local branch and then download a brand new copy with git fetch. I can show you that if I git checkout main, and git branch lowercase d to delete a new branch, Git's fine with that. There's no work in new branch that we have in the local that isn't in the remote. But if I do the same thing with newer branch, where we've committed to, it's going to say, hey, you sure? You sure you want to delete that work that you don't have in the remote? Because we know you like pushing up the changes so you can download a clean copy later. And I'm going to go ahead and say yes, just so we can clean up our Git Kraken right now. But uppercase D will totally let me delete my branch. What do we get? Merging and rebasing are how you reconcile changes. So we're finally getting to what we want to talk about. Why would you want to merge or rebase? Anytime you need to get new changes that your coworkers push the remote down in your local, anytime you want to get your new changes up in the remote, really anytime you want to smush two branches together for any reason or update a branch with new changes. At a very, very technical level, Git is saying, now kiss to two sets of changes, taking notes on how they kiss, and then slapping those notes on the end of the commit history. Remember I said that Git is obsessed with relationships. It loves the drama. It wants to write its own personal fan fiction about your changes. So, how are we going to do merging? We got git merge new branch. Great. Wherever I'm checked out, my head, we're going to incorporate those new changes from new branch. Git merge branch 1 and branch 2, we'll take both of those branches and reconcile them into wherever you have checked out. So essentially, the base is always head. The simplest possible merge is a fast-forward merge. Git always tries to merge this way under the hood, merge this way first. It uses rebase under the hood, which will make sense later. So there's no merge commit. Basically, Git is just saying, I found the last common commit. All the commits in your new branch come directly after that, and there's no new information in the base branch. This happens when you've made a branch and you're ready to go ahead and merge it in before your coworkers have had a chance to get any changes in main. So I have a branch very cleverly named fast forward merge, and we will be merging it in It's kind of hard to tell with the way that Git Kraken is doing this right now, but we have 2 commits in fast forward merge. They come directly after the last common commit, and these 2 guys are in the squash branch. So there are no new changes in main since I made the fast forward merge branch. So I'm going to go ahead and run git merge, fast forward merge, and we can see the Git printed out fast forward. And when we go to look at main, we have the local main marker is right on the tip with fast forward merge. We have 2 new commits in main, right on there, easy peasy. I will not be pushing today because I don't have internet, but if I did, and I tried to push a branch where a fast forward merge was not possible, push would just stop. It would tell me something along the lines of some refs rejected, and that's because pushing will only fast forward. If it can't fast forward, it's just going to stop. Git push is the same as running git push remote all branches. So if you're getting this error and you're like, nah, I know this branch can fast forward, then try specifying that branch. You may find that another branch is the one causing your problems. The next merge is called 3-way merge. If fast forward merging is not possible and you're not pushing, then Git will try this one next. The name comes from the 3 commits that Git is comparing, that last common commit, or the parent commit of new branch, the last commit on the base branch, and the last commit on new branch. So Git will look at the changes in main, Git will look at the changes in new branch, it'll look at how those changes compare to the last common commit, it'll take very detailed notes, and slap those notes and the changes in a new merge commit on the end of the commit history. Continuing our clever branch naming theme, we have a branch named 3-way merge. Now, we just merged into commits from fast forward merge, so we know that main has commits on it after I made this branch. Also, it came from a commit before the last common commit or parent commit for fast forward merge. So there already would have been work that was not in my current branch. So let's go ahead and run it. Oop, if I can type. There we go. So we have our commit message. Gets like, hey, I wrote my fan fiction. Do you want to give me a review or a thing to put at the beginning of my book? And we're like, no, you can just go ahead and use this not detailed commit message. I'm going to tell the window to write and quit. And then when we go to look at Git Kraken, we can see that there is a closed circle. My little default Galaga guy is not in there, and that's because I had nothing to do with this commit. Git wrote this all by itself. I was not involved. And if we look at the parent SHAs, the parent relationship here, there are 2. So that is a feature of a merge commit. Pulling. Git pull is the same as git pull remote all branches. Git pull runs 2 commands. It runs git fetch, so you get all of the new information from the remote, and it runs git merge by default. We'll talk about that later. Most people merge by running git pull origin main, which is great. You get all the new information, you reconcile your changes, everything is fine with that. I don't have internet, so I can't do that. Also, as a side note, Git tells me my branch is up to date constantly. It is more often wrong than right, so just go ahead and get in the habit of pulling every time you check out a new branch. So if I ran a pull merge, it would download all the new information from the remote repository. It would try a fast forward merge. If that didn't work, it would try a 3-way merge. If that didn't work, it would generate merge conflicts. Yeah, we're talking about merge conflicts. So Git's trying to write its fan fiction. It's looking at how everybody's kissing. It's going pretty well. And then it's like, no, that one I can't figure out. I need help. I need help with my fan fiction. I guess I have to ask my co-author, which is you. Congratulations. Each of these situations is called a merge conflict. All you have to do is delete the changes you don't want, delete the markers, which are the lines with the carets and the equal signs, save the file, run git add dot, and then run git merge continue if it's going fine. Continue and abort are 2 flags that will work with a lot of Git commands. Continue means it's going fine. I'm okay with this. Let's move on to the next step. Everything is going okay. If you are about to get panic, go ahead and use abort. You can escape, you can take some deep breaths, get some water, come back and revisit when you're ready to deal with this. So remember, it's going okay. We're going to use continue. It is not going okay. We're going to use abort. And conveniently, I have a branch named conflicts that should force some merge conflicts. So let's go ahead and run git merge conflicts. And yes, I have associated VS Code with Git. So it has opened a lovely merge conflict resolution window in VS Code. VS Code gives me buttons like accept current change, which would be the changes from the branch that I'm currently in, accept incoming change, accept the changes from the branch that I'm trying to merge in, accept both changes, which happens more often than you would think, and compare changes, which opens like a 3-window view that overwhelms me a lot, so we're not going in there. I can tell what I was trying to do with these changes, which is move the Rurouni Kenshin link up to the top and also move the home link up to the top. But I edited the same line, and Git is like, which one do you want? Just tell me which one. So we're gonna move this guy to the top. Yes, it would have been great had I installed a formatter or a linter in this example repo. Instead, you get to watch me tab a lot. Okay. And then I'm going to remove the lines with the markers. And just as a casual side note, you could add whatever changes you wanted at this point. And Git would be like, great, that's what you want. I'm going to keep them. So I'm going to save the file, run git add dot, run git commit, tell Git, yeah, sure, use your commit message with write and quit. And then when we go to get cracking, we have another merge commit here with 2 parents, and our merge conflicts have been resolved. Squashing. I love squashing. Squashing is like a compromise between merging and rebasing. It's for the team who cares about making their commit history readable without wanting to rebase, which, like, who could blame you? You add the squash flag to the merge command, and this will put all of the changes in one commit, and then let you write a new message. So instead of someone having to follow you along your journey on solving the problem that you solved, and really, they're often not nail biters. People don't want to follow you through your whole journey. You get to take all of the changes in the entire branch, smush them into one commit, and then rewrite the commit message describing the entire journey. And surprisingly, we have a branch named Squash. In it, I have 2 commits. I've decided I want them to be one commit. We're going to try and end up with one commit with a commit message that says remove fonts and add title. So git merge squash, and then again squash. And this is one of the ones that VS Code takes over for some reason. I don't know why. It has already staged all of our changes, so those are going to go in our next commit. And it has given us a very verbose message for what we're trying to do. So I'm going to delete the information about the commit itself. I should be able to view that with something like git log. And then I'm going to put an and in between these 2 guys and use the commit button, which should be the same as running git add dot and then git merge continue. And this time, we have my little Galaga guy, a commit that I have written, only one parent, and it is on the end of the commit history in main. Cherry picking is not merging, is not rebasing, is super helpful. You don't get to pick the base. The base is always going to be head, just like merging, but you get to pick any commit, anywhere, and copy and paste it onto where you are right now. But that new copy and pasted SHA, or new copy and pasted commit, is going to have a new SHA. It's going to have new relationships to the commits on the branch that's currently on. So when Git goes to write its little fan fiction, it's going to be like, these guys are strangers, not twins. I have to write everything about how they get along. And that's how you can end up with merge conflicts with 2 branches that have the same cherry-picked commit on them. Once again, we have a branch named cherry pick. I'm going to choose add link attributes, which is all the way back here in the middle of my branch. I'm going to copy that SHA. I'm going to run git, oh, not there, git cherry pick, and that SHA. And when we go back, I have add link attributes, but it has a completely different SHA than the one back here. It has a completely different parent, and might as well be a complete stranger to the commit that we copy and pasted it from. And now we finally get to rebasing. In rebasing, you get to pick the base. You get to pick the commits. You get to pick the ref you use to reference them. You get to manually do a fast-forward merge, essentially. You're telling Git the new relationship between commits. Git will then write its fan fiction based on this new drama that you have told it about. You will have to deal with the consequences of this, which is often merge conflicts. With rebase, we have to specify the base. You can do it from any branch, but you will end up checking out new branch if you specify base and new branch. If you only pass one option, you're passing the base, and the thing that you're moving around is head. So whatever commit you have checked out on the end of your branch, or if you're already checked out to one single commit, will be rebased onto that base. You can set pull to rebase. I kind of referenced this earlier, saying that it was merged by default. Here's the command that you can do it in. I can't run pull because I don't have internet, so I can't show you. But I recommend that you configure this command to match the environment that you're in. Because if people are merging and you're getting a bunch of merge conflicts, and you pull down and pull is set to rebase, then you're going to end up solving a lot of merge conflicts and stuff that would have been resolved by the merge conflict. I'm sorry, the merge commit. Suddenly, you're going to have to tell Git how the commits come together instead of just letting Git do it with that merge commit. If you're in a rebase environment and you keep this set to merge, then you are going to pull down changes and accidentally trigger a merge commit. And then someone is going to come up to you and be like, we don't do merge commits here. You have to deal with that now. You have to take that out. So match the environment that you're in. So I briefly went over the commands, but let's go through some practical examples so we can really tell what we're trying to do here. I based new branch off of main, 2 commits back. Now somebody has put changes in there, and I want it to be up to date before I open a PR, because I want to go ahead and resolve any conflicts with those changes so I don't have to deal with them after the review. So this time the branch is named rebase 1. We can see that it's all the way back here before I even started fast forward merge or 3-way merge, and I want it to be up to date. So I am going to run git rebase main rebase 1, and note that I am currently in main. When I run this command, now I am in rebase 1. If we check out git kraken, my local example has its 2 commits right up to date on the top of main versus the remote version, which is all the way back here. This is me saying, hey, Git, I based this branch off of this commit. And Git goes, really? Like, my notes say, I'm like, no. Ignore your notes. It's always been this way. It's this way now. It always has been. We're going to come up with a really contrived example for this one. Sorry. So I started some work in main. I've been working on it for a while, and somebody else started a feature branch with this really important feature. We're going to push it out later. We've decided that my work is now part of the feature. I want it based off of feature branch, because I'm going to merge it in there. That's where I want it. However, the latest commit on the end of the feature branch has some breaking changes I don't want to deal with. They're going to resolve it. I'll deal with it then. So I want to base it off of this random bit 1, 2, 3, 4, 5, 6, 7, 8. We're going to use my cleverly named branch rebase 2. And we are going to base it off of, Let's try add link attributes again. I'm going to copy this. I'm going to find my VS Code, git rebase, the base is the SHA, and the branch is rebase 2. And if we go back to git kraken, we can see that rebase 2 is now here in the middle of cherry pick. It's getting a little complicated. We got a lot of branches going on. It's a little hard to see. Don't worry. There's a new repo for interactive rebasing with 2 branches. I'm going to go ahead and open my VS Code window while we're talking about that. If it will let me right-click. Beautiful. Close this guy. And back to slides. So I told Git a small, tiny white lie. We've always been based off of this commit. It's always been this way. But when I go to push up to the remote, if I could, Git would be like, hey, no, I see right there. It was not always based off of that commit. This is a lie. So you must tell it to force. And I recommend that you just always run git push force with lease, because force with lease will try to stop you if there is work in the remote branch that will go away with your new commit history. Force will not. You'll just be like going along with your day and then remembering that there was a commit when someone's like, hey, where'd that fix go? Now we get to interactive rebasing. And I have a few warnings for you. Interactive rebasing is not just telling Git, hey, these are the new relationships. Please write a new fan fiction for me. Interactive rebasing is you write it all. It's you now. You're the fan fiction writer. Congratulations. You can delete commits. Deleting commits is a feature, not a bug. You can just drop them. They'll go away. That's totally a feature. More changes that you're rebasing interactively probably means more conflicts inside the whole process of interactive rebasing. So remember the abort flag if you accidentally trigger too much. The more conflicts you have to resolve, the easier it is to overwrite work. It's kind of like when you write a word so many times it stops looking like a word. You can do the same thing with merge conflicts, I know from experience, unfortunately. By the time you've resolved it like 10 times, you forget which option you wanted in the first place. You don't know why you're doing this anymore. It's very easy to overwrite work. Commit history can be extremely important. We saw recently with, was it X-utils, CX-utils, a security issue in free open source software, that part of the way that they were able to identify that was the commit history. There are also public GitHub repos that exist to be a historical record. So there better be a good reason that you are trying to rewrite your commit history. For this reason, I recommend that you only rewrite your local or draft PR commits. I say draft PR because I don't know about other UIs, but in GitHub, there's this handy little feature where if you're reviewing someone's PR and you've viewed a file, you can click a little checkbox that says, I've viewed this. And then when they push new changes, GitHub will go, hey, this file has changes you haven't seen. And that goes away if you force push. So your coworkers may be mad at you. I've also seen like comments disappear and stuff like that. So try to only interactive rebase commits that it's still in your purview. Nobody else is interacting with them. We're going to walk through how an interactive rebase goes, and then we're going to do a few more practical examples. 1, push up any changes you like, so you can download a clean copy if you mess up. 2, run git log or use a GUI to find the ref that you need. Pass the ref or refs to the rebase command with the interactive flag. If you want to rebase 2 branches together, it looks like a regular rebase command. If you want to just edit your commit history in your current branch, all you have to do is find the SHA of the parent commit of the commit you want to edit. Whatever SHA you pass, it's not going to print out that commit. It's only going to print out the commits after it. And you think, why? Well, why are the oldest commits at the top? The newest commits are at the top in everything else, in git log, in git ref, in git GUIs, but interactive rebase, let's just go ahead and swap that so that you can forget that when you're trying to interactive rebase. You can reorder commits. All you have to do is move the commit around. I'll show you in a minute. Every commit should have a keyword next to it when you are done. Pick is the default. It's what everything is going to load with. It means keep it. Don't mess with it. I like it. Reword means edit the commit message. Edit means use the commit, but stop before amending. If you run git commit, and then you go, oh no, I forgot to add something to that commit, it would be nice if I could just go back, add more information to that commit. You can. Git commit with the amend flag will let you add state changes and reword the commit message, which is great if you remember immediately after you made that commit. But if you, I don't know, remember when it's 3 commits back, then you got to use interactive rebasing for that. Squash is exactly like merge squash, except you get to pick a few commits, and they will merge into the commit before them. Watch me try to remember this when we get to that example. Fix-up is like squash, but just go ahead and discard this commit message. I don't need it. Just put the changes in this other commit message. That one's better. Exec is run a command. I have not seen an example of this used. I have not used it. If you know why it would be useful, feel free to tell me after this talk. I'll give you a sticker. But I don't know. It seems dangerous. Drop is delete. Get rid of this commit. I don't want to see it ever again. This is how you delete a commit. After you write and quit, you're going to have to resolve any conflicts. Then you're going to use git rebase continue or git rebase abort, depending on how it's going. If you use reword, edit, squash, anything that wants you to edit a commit message, you're going to have to write your commit messages. Then we're going to run git log again. Or you look at the GUI real close and be like, do I like this? Have I done the thing I wanted to do before you push up with force with release and tell Git that this is the new commit history? So now we're going to start with rebasing one branch onto another and reordering some commits to justify not just using the regular rebase command. We're going to use iflag. We have new branch. We have main. We want new branch on top of main instead of one commit back. So we got main, we got new branch, and now Git prints out all of the keywords that you can use, and we have our commits with the oldest commit at the top. I'm going to go ahead and use I to insert, and then use my mouse to copy this line, and then use delete to delete it, which I'm pretty sure are not Vim commands, but have consistently worked in my terminal, so I will not be learning the Vim commands for that. Then we're going to make this commit the latest commit instead of the middle commit. I'm going to use escape to leave, :WQ to write and quit. And then if we look, we have new branch up here, and update button name is the latest commit. Now, if I can find my slides, we're going to remove a commit we don't need. We're going to drop it. I came up with some contrived examples. I have enable background colors, and then I have revert background colors. So clearly we don't need this commit with enable background colors in it. So I'm going to click on the commit before it, because that is the one that will not print out. Copy that SHA. Go ahead and run git rebase I SHA. And now we get all of the commits that are currently in main, starting with the oldest one, enable background colors. I'm going to hit I for insert. Go ahead and back up and put drop. I think I forgot to say, the reason that you see P, pick is because you can use a single letter if you really just don't feel like typing out the word, which comes in handy when you're doing a lot of these. So we're going to escape, :WQ. We go back, and now we can see up here with our local history, we no longer have that commit I don't want. We're going to change an old commit message. I don't want shadowns. I don't want my coworkers to laugh at me. I want shadows. So I'm going to make sure that I am in, okay, I messed up. we're in new branch, not main. So not only did I drop a commit I didn't want, but I also rebased all of those commits onto the end of new branch, which is actually going to make one thing I usually mess up a little bit easier. But you can see all of these commits are now here, and we dropped a commit. Sorry to mislead you about what was happening. So we're going to stay in new branch because this is easier now. I'm going to copy this commit. I am going, or SHA. I'm going to copy the SHA. I'm going to interactive rebase from there. And I'm going to use reword for this one. I'm going to hit escape. I'm going to call in WQ. And now I get the same edit window we're used to for commit messages, and I can just remove that in. If I hit I for insert, escape, call in WQ, and we're out. Now I got shadows. I don't have shutdowns. I believe the last example is squash. So we're going to have to remember oldest commits are at the top. I have revert background colors, use borders on the perimeter. Only one of these typos was on purpose. And I don't like perimeter. I wanted perimeter. And I'm not using it anyway. I'm using box shadows. So if we go back here with this commit, we should be able to squash it into the commit that came before it. No, I didn't get enough commits. All right, we're just going to call in WQ, act like we didn't do that, go back one more. And if I squash this commit and squash this commit, oh, I'm already in insert mode, I don't need an I, escape, WQ, we get the exact same thing we got with squash merge, except less verbose for some reason. I don't have all of the information about the commits. I can hit I to insert, and we remember that none of the lines with the octothorpe are going to carry over. And let's say we're just going to leave add styling. No one needs to know how many wrong turns we took. Escape, WQ, and we have no more shutdowns, no more perimeters. We like our commit history now. I would push this up if I had internet. So that is my last example. The first two resources here, learn Git branching. I have heard great things from all levels of developers on how much they love this tool for learning and really visualizing the branches and what's going on. Git it. If this is your first introduction to Git, I did my best. I hope it helped. Use Git it to do all of this yourself, because then you'll have walked through the commands and understand what's happening. And you get a little certificate at the end if you turn it into the GitHub repo. The Git reference documentation, a classic. Atlassian tutorials I like because they try to say things in plain English and give you a lot of visualizations. Oh shit Git and dang it Git, if you didn't like that I just swore, are two websites by Julia Evans. She also has zines by the same name. They have a lot of great information in there. Please do not get panic. You can always find me on the internet if the 11 article blog series is not enough. And yeah, that's it. I guess I accidentally left you time for questions if you have them. But that's the end of my talk. Thanks for coming out.